I want to talk to you really quickly about the concept of the half-life. I'm sure you guys have heard of half-life before. Those of you that have some knowledge of video game history will have seen this symbol before. Of course, Half-Life is or at least was, a pretty popular game in the late 90s, early 2000s. But in terms of chemistry and science in particular, half-life is something very specific, and it refers to something radioactive. The half-life of a compound is the time for half of a radioactive sample to decay away. Alright? For example, the half-life of iodine-131, which is used in a variety of medical diagnostic procedures, is 8 days. An 8-day half-life means there will be enough iodine in your system in order for the doctor to do the measurements he needs. But after 8 days, after a month or so, there'll be virtually nothing left of it. The radioactive compounds that are really, really nasty are the ones that have half-lives that are really, 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 really long. There are compounds that have half-lives of years, or hundreds of years, thousands of years, or millions of years. And the reason why they're so dangerous is because they are giving out that radiation almost constantly, because it takes so long for half of it to decay away. A matter of days, like iodine, it's not really a big deal. But anyway, we're getting off topic. So the question here is calculations involving half-lives. So for example, if we had a 75-gram sample of iodine-131, the question is how much of that sample would be present after 32 days had elapsed. Alright? And so really all we're looking for is here, how many half-lives have occurred. If we can figure out how many half-lives have occurred, we can see what's going to happen to our amount of sample. Alright? So after 8 days, I'm going to put an arrow here for each 8-day period. Right? 8 days. 8D for 8 days. Alright? We're going to call this half-life number 1. Half-life number 1. Now, the half-life means your sample decays down by half. So after 8 days, half of the 75 grams will be gone. Now half of 75 is 37.5. So that's how much iodine will be left after 8 days. Alright? Now, after another 8 days, essentially that's half-life number 2, there's going to be half of 37.5, which is about 18.75 grams. All right? More or less. But we aren't asking about 8 days or 16 days. If you think about it here, it's 8 days plus 8 days is 16 days. If we do another 8 days here, half-life number 3, that then becomes 8, 16, 24. Now 18.75 divided by 2 is, bollocks, what is that? It's about 9.3875, maybe something like that. Not entirely sure. Something like that. But that's still only 24 days. One more half-life. Half-life number 4, essentially, is going to take us down to half of this. So, of course, I don't have my calculator with me, so half of 9.3875, well, that's 4.5. 4.5, I don't know, 4.6, bollocks, 4.65 grams, maybe something like that. I don't know the actual amount. So, the reason why we know this is 32 days is because this is 8. That then becomes 16, that's 24, and that's 32. So that means 4 half-lives have occurred, 8, 16, 24, 32. We started off with 75 grams, and after only 4 half-lives we have very little left. Alright, so that's how quickly things can decay down. Alright, let's do another one. Carbon dating. This is something I'm sure you've all heard of before. Carbon dating is used to determine how old things made out of plants are. So, for example, carbon-14 has a half-life of 5,730 years. If a piece of fabric is found to have 1/16 of its original carbon-14 activity, how old is the piece of fabric? Well, what we have to figure out from this is, what does 1/16 tell us about how many half-lives we have gone through? Well, if we start with our amount that we have, notice the question doesn't tell us how much we had, but it does give us this little nugget here. So that tells us we can start from 1. After one half-life, what do we go to? Well, of course, we go to half. After another half-life, we go to half of a half, which is a quarter. After another half-life, we go to half of a quarter, which is an eighth. And then after another half-life, we go to half of an eighth, which is 1/16, which is exactly what the question is asking us. So then we just have to figure out, well, how many half-lives is that? Well, it's just a case of adding up our years. 5,730 years for the first half-life, and for the second, and for the third, and for the fourth. So really, all it is 5,730 times 4, which is going to give you about 22,920 years. All right, that's how old it is. Now, of course, this is 3 significant figures. If you had to express this to 3 significant figures, it would be 22,900 years old. All right. But that's the way that works. Okay, last one here. Fluorine 18. This has a much shorter half-life. So you've got carbon-14 with a half-life in a matter of thousands of years. You've got half-life of iodine, half-life in the matter of days. And then we've got fluorine 18, which has a really short half-life of less than 2 hours, 110 minutes. For a 100 milligram sample, notice there's the dot here. That means 3 significant figures. If a 100 milligram sample of fluorine 18 is shipped at 8 AM and arrives at its destination at 1:30 PM, how many milligrams of fluorine are still active? So again, we have some time questions here. We have to figure out how many half-lives have occurred. Well, from 8 AM to 1:30 PM, that is 5 hours and 30 minutes. So 5.5 hours. All right. So 5 hours, 30 minutes. Now the reason why I'm doing this is because our half-life is in minutes, so we've got to convert all this into minutes. Now 1 hour is 60 minutes, 5 hours is 300 minutes, so therefore the total time that this is in transit is 330 minutes. So if we start off with 100 milligrams, after one half-life, that's 110 minutes. We've got half of 100 milligrams left. We've got 50 milligrams. After another half-life, which is going to be another 110 minutes for a total of 220 minutes, we've got 25 milligrams left. Then after one more half-life, which gives us a total of 330 minutes, which not surprisingly is exactly this number here, we have 12.5 milligrams left. So even though this has only undergone 3 half-lives, we only have an eighth of it left. So that's calculations involving half-lives. It's not that difficult, you just got to know what to look for from the question.